Well, hello everyone. And now it's time to learn how to write formulas for any compound. That's right. You see, up till now, all of the compounds that you've been writing formulas for have been categorized. There are three categories we've looked at: ionic compounds, acids, and molecular compounds. And for all the practicing that you've done and all the work you've done so far, each of those categories has been made clear. What you want to be able to do, however, is to look at any compound without being given its category and then determine how to write its formula. So how are you going to go about doing that? Well, that's what this video is meant to teach you. It basically happens in two parts. First, you'll determine the type of compound that you're looking at. Okay, when given the name of a compound, I'm going to show you how to determine if it's an ionic compound, an acid, or a molecular compound. And then you have to apply the appropriate rules that you've learned in previous videos. To help you with this is this here flowchart that you see in front of you. Okay, it's called the formula writing flowchart. And what you should do is every time you look at the name of a compound in the practice materials is you should look at this flowchart, start up here at the very beginning, and then follow it. And you do what it says, and you'll end up writing the correct formula for any compound. This flowchart does not have every bit of information that you need, that you're going to need. So you will have to refer to your notes or some of your previous practice materials, though I did try to include quite a bit of stuff here to help you along the way. Let's jump right in with some examples and we'll see how this works. We'll start with this wonderful compound here called diphosphorus trioxide. So we'll start right here. This looks like the beginning. And we'll say, hey, does the name have the word acid in it? I don't see acid, so that's a no. Are there prefixes in the name like di, tri, or tetra? Yes, I see a di right there and a tri right next to it. That's right, di and tri. So that's a yes. So that means we're going to use the prefixes to represent subscripts. Di means 2, and phosphorus is symbolized with P, so we'll write P2. Tri means 3, and oxide refers to oxygen. We'll write O3. That's it. There you go. That's all you have to do for that one. Next example, hydrosulfuric acid. All right, starting at the beginning of the flow chart. Does it have the word acid in it? Yes, I see acid right there. So that means that hydrogen will be the positive ion. So let me just write down H+. That's our positive ion. Does it begin with hydro? Why, yes, it does. There's hydro. So we'll go with yes, yes, yes. Okay, so we're going to use an element as the negative ion, and we're going to do the crisscross method. All right, so sulfuric, that would refer to sulfur. All right, and what's the charge then on sulfur? Well, that's where our friend the periodic table comes in handy. Aha, that's in the -2 column. So let's put -2. Let's do the old crisscross technique where the subscripts crisscross each other and switch places, and we get rid of the positive and negative charges, and a 1 becomes invisible. And there we go. Hydrosulfuric acid's formula is H2S. I apologize if that looks like a 5. That's my bad handwriting kicking in there. That's an S. Next example. Ooh, this one looks tricky. Iron 3 phosphate. It's not that bad. Does this name have the word acid? No. Are there prefixes in the name like di and tri and tetra? Nope. So what do? Well, we determine the ion charges and we do the old crisscross technique. Crisscross technique, if you remember, involves things like reducing when necessary, getting rid of the positive and negative signs, so on. You can read the stuff down here on your own. Sorry about the stuff getting in the way. Okay, so iron 2. Well, let's see, iron 2, that's Fe, and the 2 means +2. And phosphate, hey, that sounds like a polyatomic ion. Maybe I should look that up on the polyatomic ion chart. Phosphate, there you are, phosphate. PO3, I'm sorry, phosphate has a PO4 as its formula and a -3 charge. So we'll put PO4 in parentheses, and we'll have a -3 charge. Now we can crisscross those two charges. Fe gets a subscript of 3, and PO4, because it gets an additional subscript of 2, retains its parentheses and gets the 2 on the outside. There you are. There's iron 3 phosphate. Next example, calcium carbonate. Good stuff. All right then, do we see acid in this name? No. Do we see prefixes? No. Once again, no. So we determine ion charges and crisscross, much like the last one. So let's see, calcium, what's your symbol? Ca. And Ca, what's the charge on Ca? Good old periodic table tells us calcium +2. Carbonate? Sounds like a polyatomic ion. Let's go check it out. Polyatomic ion. Oh, there you are, carbonate. What is your formula? CO3, -2 charge. CO3, parentheses, -2 charge. And now the 2 and the 2 can crisscross, and hey, I'm looking ahead, the 2 and the 2 are going to reduce to 1 and 1. So I'm just going to write Ca, CO3. There we go. Oh, but wait, what about the parentheses? Shouldn't you have parentheses? Not this time, because the carbonate, CO3, ends up with a subscript of just an invisible 1, so there's no need for parentheses. Will you mark it wrong if we have parentheses like this right here? Yes, I will mark that wrong. Not acceptable. Sorry. Hashtag. All right. Last example, and then you'll get to try some on your own. Chromic acid. Do we see the word acid? There it is. So that means we're going to need a hydrogen ion in the what do you call it? Positive ion position. Does it begin with hydro? I don't see no hydro. Okay, so that's a no. So we're going to use a polyatomic ion as a negative ion, and we're going to do some crisscross technology. Remember, 8 means ik and ite means us. So we have an ik in the name of the acid. Ik corresponds to 8. So let's go to the So chromic, what is that? That would then be chromate. Chromate? Is that even a thing? Oh, surprise! There it is. Chromate. Oh, so cute. Look at it. CrO4, -2 is the charge. So let's put CrO4, hey, polyatomic ion. Let's wrap it up to begin with. -2 charge. And we'll crisscross, and then the hydrogen then receives the coefficient of, or subscript of 2, and then chromate, the polyatomic ion, that's going to end up with a 1. So guess what? We don't need those parentheses. CrO4. There's chromic acid. Ladies and gentlemen, you're going to get lots of practice materials, and if you utilize this flow chart over and over and over again for every practice item, you'll eventually start to remember it, and eventually you won't need it. It just takes time, practice, and patience, and emailing me with any questions. That's all for now. That means have a nice day. I hear the dog barking upstairs.